Okay, let's dive right in. We are surrounded by these incredible structures, but the one thing they all rely on is almost always completely invisible. Today, we're going to pull back the curtain on the hidden science that literally supports our entire world.
So let me ask you a question. When you see a massive skyscraper or you're driving over a huge bridge, what do you think is really doing all the heavy lifting?
Now, your first thought is probably the steel beams, right? Or the tons and tons of concrete. And yeah, you're not wrong. But that's not the whole story. Not even close. The real foundation is something else entirely.
Believe it or not, it's the ground itself. But not just any old dirt. We're talking about engineered earth, transformed into a high-performance material through a process called soil compaction.
So what is that? Well, the key thing to get here is this. Compaction is all about applying a ton of energy to squeeze the air out from between the soil particles. Think of it like this. Less air means more soil packed into the same space. And more density? That means more strength. So, how do you actually do it? Well, it's kind of like a simple three-step recipe for creating super strong ground. First, you have to know your soil type. Then, you add the perfect amount of water. And finally, you bring in the right kind of force.
But here's the cool part. Not all force is created equal. It completely depends on the soil. For granular stuff, like sand and gravel, you need vibration. You got to shake those particles so they settle in nice and tight. But for sticky soils like clay, vibration does nothing. You need a powerful kneading action to kind of break them apart and then mash them back together.
And that, of course, directly determines the kind of multi-ton machine you bring in for the mission. You've got these huge vibratory rollers to shake the sand, and then for clay, you use what are called sheep's foot rollers, which are pretty much what they sound like. Giant, heavy metal feet that just knead the ground. It's awesome science in action.
Okay, now for what I think is the most interesting part, the role of water. It's all about what I call the Goldilocks principle. You've got to get it just right. Think about building a sandcastle, right? If the sand's too dry, it just crumbles. And if it's too wet, you've got a soupy mess. It has to be just damp enough to hold its shape.
It is the exact same principle here. Water acts like a lubricant, basically helping all those little soil particles slide past each other and pack in super tight. But there's a perfect sweet spot. Too little water and the particles can't move. Too much water and they just float apart. Get it wrong on either side and the soil's strength just plummets.
Okay, so why are we obsessing over this? Why does all this matter so much? Well, because when it comes to construction, the stakes are incredibly, incredibly high.
It's simple, really. When compaction is done right, you get those smooth, durable roads that last for years, and buildings with foundations that don't move an inch. But when it's done wrong, that's where you get potholes, cracked foundations, and sometimes even catastrophic failures. It is literally the difference between safety and durability, and failure an enormous cost.
So, the next time you're driving on a perfectly smooth highway or you're standing in a massive, sturdy building, just take a second to remember the invisible science working hard right beneath your feet. It kind of makes you wonder, right? What other amazing invisible sciences are out there, hiding in plain sight, just holding our world together?